All right, today we're jumping into something really cool. It's a paper from Meta AI called Toolformer, and it unpacks a huge paradox at the heart of AI. It also shows off a seriously clever way for language models to teach themselves totally new skills. So yeah, let's get into it. Okay, first let me ask you something. Just imagine a genius, someone who knows all of world history, can whip up a perfect poem in a heartbeat, and explain quantum physics like it's nothing. But they can't figure out how to use a calculator for a simple math problem. Sounds kind of ridiculous, doesn't it? Well, believe it or not, that absurdity is pretty much the reality for a lot of the large language models, the LMs we're all hearing about. They are absolutely brilliant in some ways, but in other, very specific ways, they are just totally stuck. So that brings us to our first section, where we're going to unpack this weird split personality of modern AI. Just look at this. On the one hand, these models can do some mind-blowing stuff, writing poetry, summarizing dense articles, translating languages. It's all based on the mountains of text they learned from. But then you look at the other side and you see these glaring weaknesses. They can't do precise math reliably. They have no idea what today's date is or what happened in the news this morning because, their knowledge is basically frozen in time. And sometimes they just make stuff up. So what's the fix? Well, it seems pretty obvious, right? If the genius can't use a calculator, you just give them a calculator. And that is exactly what researchers are starting to do. In the Toolformer paper, they gave the language model a simple but effective digital toolbox, and each one of these tools is meant to fix a specific problem. Need to do some math? Here's a calculator. Need some up-to-date facts? Here's a search engine. You get the idea. And here's what that actually looks like in practice, and it's so cool. The AI is writing a sentence, and it realizes, hey, I need to do some division here. So it just pauses, seamlessly writes a little command, that's the API call, to the calculator, gets the result, and boom, plugs it right back into the sentence. That part in the brackets, that's the AI literally using a tool as part of its thought process. Okay, but this whole idea has a massive catch, a billion example-sized problem. How in the world do you teach an AI to actually do that? Right, this is the real challenge. I mean, it's one thing to just hand over a toolbox, but how does an AI develop the common sense to know when it should use the calculator versus when it should use the search engine? And what should it even ask? How do you teach it that kind of intuition? While the old school way was just a total grind, you'd literally pay an army of people to sit there and spoon-feed the AI millions of examples. They'd go through text and manually add notes like, hey, this would be a good spot to use a calculator, over and over and over. As you can probably guess, that's insanely expensive. It's super slow, and it just doesn't scale. And this is where the genius of Toolformer really shines. The researchers figured out a way for the language model to just teach itself. No humans needed. The whole secret is this simple but kind of brilliant three-step loop. First, the model just reads a ton of text and basically guesses. It samples thousands of spots where maybe, just maybe, a tool could be helpful. Then it actually tries all of them out. It executes the API calls and sees what answers it gets back. And finally, here's the magic part. It filters all those attempts and only keeps the ones that were actually helpful. But wait, how does it know what's helpful? That's the big question. It all boils down to this one key concept in AI called loss. The easiest way to think about loss is as a surprisometer. When the AI is really confident about what word comes next, its surprise is low, so the loss is low. When it's totally unsure, surprise is high, and the loss is high. And the AI's one goal in life is to keep that surprise, that loss, as low as possible. This example makes it super clear. Look on the left. When the AI gets to the capital of France is, it's kind of guessing what might come next. Its surprisometer, the loss, is high. But now look at the right. This time it first uses its Q&A tool, asks capital of France, and gets the answer Paris back. Now it's not guessing anymore. It is absolutely certain the next word is Paris. The surprise plummets, the loss goes way down. The AI sees that and thinks, aha, that was a good use of a tool, and it saves that example to learn. And that's the whole trick right there. The AI is literally writing its own textbook. It's creating thousands of its own practice problems, and then it's grading them based on a simple rule. Did using this tool make me less surprised? If the answer is yes, it keeps it. It's all done automatically. It's completely self-supervised. So you might be wondering, does all this actually work? Oh yeah, and the results are kind of shocking, actually. We're talking a real David versus Goliath showdown. So in one corner, we've got our David, Toolformer, built on a relatively small 6.7 billion parameter model. And in the other corner, the heavyweight champion of the time, Goliath, GPT-3, which clocks in at a staggering 175 billion parameters. I mean, it's more than 25 times bigger. So let's see what happens when we test them on pure factual knowledge. It's not even a contest. The little Toolformer with its simple Q&A tool just blows past the much bigger GPT-3. A score of 53.5 to 39.8, that is a decisive win. And if you thought that was wild, check out the math problems. This is an absolute landslide. Toolformer, using its calculator, scores over 40. GPT-3, trying to do the math in its head, gets stuck down at 14. This is the perfect proof that working smarter, not just bigger, is the way to go. A smaller model with the right tools can absolutely dominate a bigger one without them. So, what's the big picture here? What does all this tell us about the future? Well, it's pretty clear that the path forward isn't just about building bigger and bigger AI brains, it's about building smarter ones that are connected to the real world. Now, let's be real, this approach isn't perfect. Not yet. The paper is upfront about its limitations. For example, the model can't chain tools together, like looking up a number and then plugging that number into the calculator. It's also not interactive. It gets one shot at its search. But you can see these as just the next set of engineering problems to be solved. But the most important thing, the key takeaway from all of this, is that the model learned all these new tricks, math, search, checking the calendar, without forgetting how to be a great language model. It didn't have to make a trade-off. It got the best of both worlds, the creative fluency of an LM, plus the factual, grounded precision of real-world tools. And that leaves us with one final, pretty massive question to think about. We've just seen what happens when an AI learns to use a handful of very simple tools. But what happens when it learns to use everything? I'm talking about every app on your phone, every program on your computer, every API in the world. What does that future look like?